Hello and welcome to How is an Action Potential Generated? I'll be going over the key marking points whilst drawing the process out for visual understanding. So grab a pen and come draw along with me. So I'm going to start by drawing what looks like a graph of a heartbeat, so essentially the action potential graph. The first marking point in how an action potential is generated is the membrane is at a resting potential of minus 70 MV. I'll just go ahead and label it on here, RP for resting potential. Now step 2 is a stimulus is applied which exceeds threshold value of minus 55 MV. What this means is like a pressure or a change in the environment, external or internal, let's say has enough force to change the potential difference of minus 70 to minus 55 MV. So then what this stimulus does is it opens the sodium ion voltage gated channels and allows sodium ions to diffuse into the axon. And people get mistaken I get mistaken if it's sodium or potassium, and I just think it's all about the salty little sodium ion that wants to depolarize the membrane. Which then leads us on to step 3 and the third marking point, which is the membrane depolarizes. And what that means essentially is the membrane potential of the neuron becomes less negative. So it goes from minus 70 to minus 55 when the stimulus is applied, and now it's at plus 40 MV, which is where an action potential is generated. So an action potential is when the inside of the axon is more positive than the outside, so it's had a reversal of charge. You kind of have to think of in biology how everything is consequential and everything happens after the other because the step before happened. So in an exam, I like to think, so because of this happened, what happens next? And because that happened, because it's just all consequential. So now that the axon has reached an action potential and it's been generated, we need to think about bringing the membrane back to its original resting position of the minus 70 MV potential difference. And the membrane does this by closing the sodium ion voltage gated channels and opening the potassium ion voltage gated channels. This allows for the potassium ions to diffuse out of the membrane, causing repolarization of the membrane, so the inside is more negative now than the outside. However, it's not that simple, since I like to think the potassium ion is a SWAT and it's trying to save the day because the sodium ion, the salty little sodium ion, has depolarized the membrane and ruined the potassium ion's day, and the potassium ion tries to save the day, but it overshoots. And so the potassium ion has hyperpolarized the membrane because it was just too invested in saving the day. And that is what step 6 is in the generation of an action potential. And because of hyperpolarization, the membrane cannot depolarize. And this is caused by the overshoot, which occurs because the outward flow of potassium ions leaving the axon reaches equilibrium before the resting potential can be restored. And the way the membrane restores resting potential is due to the sodium ion potassium ion pump, and it's very important in mark schemes that you include the term ion rather than sodium potassium pump.